Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by ngrok. My name is Cody, and welcome back to Techstrong Learning. Before we dive into things, I have just a couple of notes I'd like to review with everyone. First of all, we are recording our session today. So if you miss any of our discussion, if you'd like to watch again later, or if you'd like to share with your team, we'll be sure to send you the on-demand recording via email as soon as that becomes available today. Now, if you'd like to be involved, there are a couple of ways to do so. The first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining us from today. Now, if you have any questions, we do want you to submit those to the Q&A tab on the right side of that chat section. We've got some time set aside toward the end of our program to hold kind of a formal Q&A session. So be sure to send those in as you have them, and we'll do our best to answer as many as we can today during our live time together. Now, additionally, if you jump to that handout section, you'll see there are a couple of additional resources, so feel free to grab those. And we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So be sure to send in your chats, your questions, and at the end of the program, you'll hear more about our post-webinar survey. So our topic today is empowering app and API developers with developer-defined API gateways. I'm joined today by Karthik Krishnaswamy, Head of Product Marketing at ngrok, and also Russell Savage, Head of Product at ngrok. So Karthik and Russell, thanks to you both so much for joining us today on Techstrong Learning. Karthik, do you want to dive us right into the material?
Sure. Good morning. Good afternoon, everyone. Thank you, Cody. I'm Karthik Krishnaswamy. I head product marketing at ngrok. Very excited to present this webinar on developer-defined API gateways. So let's dive right in. Move the slides here. So let me start with a quick introduction to ngrok. Our origin is different from most tech startups you see out there. Our founder, Alan Shreve, started working on ngrok as a project to solve a developer problem, enable access from services like Twilio to apps running in your local machines, developers' local machines. So making it easier for developers to, for example, test webhooks, share their apps with others so they can easily collaborate on app previews. We've come a long way since then. We've become incredibly popular with developers. Over 5 million developers use ngrok today. Also, large enterprises also leverage ngrok for delivering mission-critical workloads that run anywhere, within the corporate network, over a multi-cloud environment, or even in customer networks and on IoT devices, point-of-sale systems in cafes, and robots in factories. So we've come a long way from being a simple developer tool for testing webhooks to now serving trillions of requests powered by a global service. Let me now turn to the topic of this webinar, starting with the state of API delivery today. Right. I want to first highlight how pervasive and widespread APIs have become. You all probably know this. APIs play a big role in our lives. E-commerce, banking, food delivery, even hailing a cab, all rely on APIs. Gartner reports that 94% of organizations now utilize APIs. We have research from MuleSoft indicating that on average, API projects currently generate close to 40% of an organization's revenue. This is up from 35% just in 2022. And the next wave of APIs is going to be powered by, you guessed it, Gen AI. Gartner again predicting that more than 80% of enterprises will have used Gen AI APIs or deployed Gen AI-enabled apps by 2026. So let me paint a picture of the evolution of API delivery. In the early days, which actually wasn't that far back, APIs have been around for a long time, as you probably all know. They really gained salience, prominence in the last 20, 25 years. In any case, in the early days, developers would build these APIs, and a simple load balancer would be deployed to manage traffic for these APIs. So you have developers building these APIs responsible for the business logic, whether it's a pricing API, retrieving pricing information, or checking out all the items in your shopping cart, if it's a mobile app, whatever the case may be, they would build the business logic and sort of throw it over the wall to operations teams, IT operations teams, NetSecOps teams, who are responsible for ensuring performance, security, resiliency, observability of these APIs. And all of this was accomplished by just sticking a simple load balancer to front all the API traffic. Well, things have definitely changed, evolved from those days. We now have dedicated infrastructure called an API gateway. Some of you, again, may be familiar with this, to secure, scale, manage API traffic. API gateways perform a number of functions, from authenticating client requests, are you really who you say you are, providing fine-grained access control, do you have access to pricing API, do you have read access, write access, routing all the requests to the right origin services, and a variety of other functions. I'll cover all of this in detail later, but the key takeaway here is this dedicated infrastructure, usually software, called API gateways to manage API traffic. There's also a significant shift in software development practices. Developers, as I mentioned earlier, primarily tasked with building the business logic, are also now responsible for ensuring performance, security, resiliency, observability of their APIs. They have to write code to address these, what I call non-functional requirements. And they rely on the ingress layer, whether it's load balancer, or in the case of APIs, API gateway, to fulfill these requirements. So the API gateway almost becomes a part of the API, right? It serves as an extension of the API. But the API gateway, given that it's infrastructure, and operations teams still retain control, manage all the infrastructure in an enterprise, including API gateways. So while developers have to use API gateways, leverage their functionality, they can't. They face some challenges as the operations teams retain control over these API gateways, and therein lies friction, tension between these teams. And because of this friction, with developers not having control, it raises several challenges for enterprises. First, it leads to reduced development velocity. Developers have to rely on operations teams to deploy, provision, configure, manage hundreds, thousands of these API gateways. A large organization could have many API gateways. Various different teams could use could use a variety of API gateways. So what would happen is developers would build these APIs and file tickets, submit tickets to operations teams to deploy APIs and deliver these APIs to production. Sometimes it usually takes weeks. Sometimes it could even stretch to months before these APIs get deployed to production, really slowing down release velocity and slowing down innovation. Second, there's operational overhead and friction. Because developers don't have direct control, they're not able to take advantage of all the amazing API gateway functionality, such as rate limiting, job authentication, to really fine-tune, optimize their APIs to provide a better experience for API consumers. Lastly, it also leads to security, performance, availability issues, and security issues as well. Because of the broken contract between the delivery infrastructure API gateway and the API itself. So what do I mean by a broken contract? Let me explain. Every API expects the request that's coming in to contain certain specific parameters. So for example, you could have an API service that expects a custom HTTP header field, which indicates the authenticated user for every request. Again, it could be my favorite pricing API example. You may want to provide access only to authorized users. And the request that's coming in, you want to have the email ID of the user that's trying to access this pricing API. This custom HTTP header field is configured in the API gateway. So someone could accidentally change this configuration or remove it that breaks the service, or worse, allows unauthorized users to access your API. So the risk of misconfigured APIs increases. That then leads to slowness, outages, unauthorized access for your API services. Another challenge that developers and operations teams face, what I call they're faced with a pick your poison pill dilemma. The choice of API gateways that are available to them, it's between deployable gateways and cloud-based gateways. Both have their strengths and weaknesses. Deployable gateways are powerful, flexible, they have a ton of features, they offer environment independence, but they're complex to manage. Operations teams have to, again, deploy, provision, configure these at scale. There's a steep learning curve. Many of these deployable gateways have plugin dependencies. Any interoperability issues with plugins, that sort of the API gateway stops working if you have any of these interoperability issues with plugins. They also come with high fixed costs. You have to commit to a certain volume of API calls and negotiate the price for this volume of API calls upfront with the vendor, right? So that results in significant investment again upfront. With cloud-based gateways, they are easy to get started, simple. They come with a pay-as-you-go pricing model, but they have a limited feature set, especially not optimized for developers. And they lock you into their own environment. Delivering APIs across a multi-cloud environment is challenging, if not impossible. So neither developers nor operations teams are happy with the sort of limited choice with all the constraints they pose. So how are we solving all these problems? We are shifting the paradigm with developer-defined API gateways, right? So ngrok brings secure connectivity with just one command or one function call to your local host, CI, production, multi-cloud environments, wherever your APIs are running, right? So there's no need to open firewall ports or modify any firewall rules. For far too long, developers have been bogged down with using primitive networking tools designed for a different era. You have to fumble around with IPs, ports, DNS, firewall configurations, or chain together several different proxies. If I ask you to write files by directly manipulating inodes and blocks on disks, you're not going to be happy. That is not a very efficient way of doing things, right? But developers are still faced with something similar when it comes to networking tools. So that's what ngrok fundamentally is trying to solve. And again, with ngrok, just one command equips you to deliver apps and APIs instantly. And while we empower developers, it is achieved within the guardrails established by ops teams to ensure adherence to corporate policies. So let's look at how this developer empowerment enables you to sort of maximize business outcomes by giving developers control over API gateways. First, you're able to accelerate development velocity. You're able to eliminate the operational overhead and friction that I talked about. And you are also able to prevent security, performance degradation, and uptime incidents, outages. Let's look at each of these in detail. With developer self-service, by granting autonomy to developers, you're able to free them from the constraints that they face today. They no longer have to rely on operations teams to deploy their APIs to production and deliver these to production. They no longer have to file tickets and wait for weeks, months. We also equip at the same time operations teams to create policies that ensure compliance with enterprise security procedures and practices. Again, this developer autonomy is granted within robust security, control, and governance guardrails put in place by operations teams, right? So it's a win-win for both teams, enabling, accelerating API release velocity, accelerating development velocity, ultimately accelerating innovation. We're also able to eliminate the operational overhead and friction by giving control to developers. They're able to take advantage and exploit all the API gateway features, such as rate limiting, JOT authentication, that Russ will go over in a bit, to really be able to deliver APIs in a flawless manner and ensure that the API consumers provide a great experience for API consumers. Lastly, you're able to prevent the security, uptime, performance issues by eliminating the hidden dependency between the gateway and the API. You can embed ingress directly in your code, so that custom HTTP header field that I talked about, nobody can go and modify, change the configuration of the API gateway. It's directly in your code, right? So you're able to eliminate those misconfigurations and prevent, again, slowness, outages, etc. ngrok also gives developers and operations teams the best of both worlds between, deployable gateways and cloud-based gateways. To revisit their strengths, deployable gateways, powerful, flexible, provide environment independence. Cloud-based gateways, simple, come with a pay-as-you-go pricing model. Combine the advantages of both of these gateways, strengths of both of these gateways, to then give you these following benefits, right? Talked about direct developer control. It's a powerful and flexible set of features that are configurable via our traffic policy engine. I'll go over that in a bit. All our features, Russ will demo that. Environment independence, really be able to support multi-cloud environments easily without requiring bespoke configurations for your AWS or Azure or your production CI. It's all just one configuration. As a service, there's no need to deploy, configure hundreds, thousands of these API gateways. Really eliminate operational burden as well as API gateway footprint. And we also offer a pay-as-you-go pricing model. You pay for active endpoints and only successful API calls. Not all API calls, just successful API calls. So easy for you to get started and scale on demand. What are some of the key features of our gateway? First, authenticate client requests. Verify the identity of a user or a service. Are you really who you say you are? Route all the requests to the right origin service. JOT validation, OIDC, most popular widely used authentication protocol. Developers use this framework to authenticate their apps and APIs, and OIDC uses JOT. They contain identifiable information about the user, so we can easily integrate into existing authorization workflows that are built using OpenID Connect. Rate limiting, you achieve multi-tenant system resilience by fairly distributing access across all your clients. It essentially controls how many requests or calls each client can make, ensuring equitable resource usage, right? And lastly, request response manipulation. Say, for example, if you have a customer-facing SEO-friendly URL endpoint, you convert that into the actual URL of the origin service. And all of this is powered by our traffic policy engine. Flexible, cell-based, common expression language, that's what cell stands for, but that has tremendous expressive power to control, shape traffic flows, right? So cell is a powerful tool for logic, decision-making. It enables you to write concise expressions that evaluate data and performs actions. Cell syntax, simple, familiar. It resembles, familiar languages like C++, Go, Java, TypeScript. Avoids complex programming concepts. Focuses on straightforward expressions. It's safe and secure. It restricts certain functionalities to prevent code injection. You can perform unbounded loops or recursion, so ensuring predictable behavior. Portability. Cell expressions can be evaluated in different environments, programming languages, right? So it's really designed for simplicity, speed, safety, portability, but it also has tremendous expressive power. It supports a wide range of data types and operators, allowing you to define complex logic. And all of the API gateway features that I talked about can be configured using this cell-based traffic policy engine. But enough of me talking. I'll now turn it over to Russ, who's going to demo all of these amazing capabilities. Ras, take it
Yeah.
away.
All right. Thanks, Karthik. Thanks for walking us through that. Really excited to jump in and actually give hands-on, show everybody what we're talking about here. All right, let's get started. So I love demoing ngrok. Super excited. We're going to start with a very, very simple API. I myself, I guess you would call me a little bit of a recovering developer. Most of the time, I'm just copying, pasting code around. But I was able to hack together a simple domain info API. So what this does is takes a domain and looks up a bunch of information about it and presents it back in a JSON format. So let's see if that's actually up and working. So in this case, I'm going to jump right over to code. It's not pretty code, but it's probably code that everybody here has seen at least once or twice. Express.js, very common web framework for building APIs. And so in this case, it's a very, very basic Express.js service. And all it has is one route that handles all of the stuff for checking the domain. So let's see what that actually looks like. As a developer, right, I'm constantly looking at localhost, opening up ports there, testing and verifying that what I'm building is working. And in this case, is no different. This is exciting for me, but I can't see anybody's faces out there. But me showing something on localhost, not super exciting. So let's start using ngrok. One of the main ways that that people discover ngrok is through sharing their the services that they're building locally with friends, colleagues, anybody in the world, and that's kind of where we'll start here. Very basic example of how most people get started using ngrok. So in this case, after I've downloaded the local ngrok agent, I jump over to my terminal, and again, simple command, but extremely powerful. And we'll walk through kind of what this does. So in this case, I'm telling ngrok to take my whatever's running on port 3000 and make it available at this demo.rsavage.dev. And let's see that in action. So this is up and running. You can see that I'm forwarding traffic from my demo.rsavage.dev to my local host, which is where I was running here. And now, when I actually jump over to call this from rsavage.dev, I get the same result, which is not very interesting for me. But I think the more interesting thing is when everybody here in the webinar accesses that, they should also get the same result. And so that command, that one single command, makes my local service available to anyone in the world instantaneously, which is really exciting. And let's talk a little bit about at a super high level how that actually works. So this is the I don't know if I would even call this a 100 level course. This is the most basic explanation of how ngrok works. I get this question a lot as a PM, like how does it do the things that it does? And so I'll walk you through kind of what just happened there when I actually ran that command in my terminal, right? So in this case, I have my local origin service. This is going to be my local API. I've got my ngrok agent. That's the little piece of software that's running right next to my origin service. And when I run that command, what it does is it reaches out and creates an outbound connection to the ngrok cloud. I've got my auth credentials in there and all that sort of stuff. So it verifies that that I'm an active member of ngrok and that I'm allowed to do this. And then it instantly makes that available on the ngrok network, that endpoint, demo.rsavage.dev. And it's not just one place, right? ngrok has data centers all over the world. And so that endpoint is actually live for anyone in accessing any data center all over the world. So somebody mentioned that they were talking about it's dependent on where the traffic is running. Behind the scenes, ngrok is operating a global load balancer service. And so anyone in the world will access the ngrok data center that's closest to them. And that traffic will route through our data centers and directly into my machine, which is pretty exciting. And hopefully, when I get back to my machine, it's still standing because everyone's trying to access it. So back to this, I've got my endpoint that's available to the internet. I've got you all in this webinar, customers that access my endpoint from anywhere in the world. The interesting thing is that what happens at the ngrok edge before it actually forwards any traffic to my local service is that it verifies the request is coming in. It applies any policy or any configuration that needs to happen. All of that configuration and all that policy evaluation, that happens at the ngrok edge, right? The agent doesn't do anything other than accept requests and forward them to the origin service. So only valid traffic comes from makes it over to my local ngrok agent through a secure connection, and then my ngrok agent then forwards it to my actual service. So that is the I guess 50,000 foot view of what happens when you actually run the ngrok command. That it connects into the ngrok service, validates that you're able to connect, makes your endpoint available all over the world, and then anyone can access it and see what's going on. So since that's the case, if you all have been hitting my API, let's start applying some of that policy, right? I don't have any policy applied to my API right now, but let's start applying that policy to my API service and see what we can do. So in this case, we'll start with a super basic policy that I can apply. My API, as basic as it is, only handles GET requests, and so anyone who's run a web server that's open to the internet will see random requests all over the place of people trying to access it through various methods. And so in this case, let's just lock it down to make sure that only valid GET requests get to my upstream API. This is an extremely basic example, but it kind of illustrates all of the different pieces that Karthik touched on for our policy. So the main things to look at here. So one, you notice this at the very, very top of our policy, we've got inbound. Now, policies can execute on traffic that's coming into my origin service, or outbound, out of responses that my service gives. And so all of the examples today are going to be inbound because that's a little bit more interesting. But you can apply these patterns to anything that's leaving your service as well and going back to your users. This expressions section, right? This is where you add the cell expression or expressions to figure out which traffic you're going to apply this to. So in this case, I'm just looking at the request, I'm looking at the method, and if it doesn't equal get, right? So if it's post or options or whatever other HTTP verbs there are out there, it's going to actually run this action. And you can put 1 to 100 expressions here. They'll all execute, and as long as they evaluate true, then the action will be applied. This action, in this case, is a custom response, and actions are where you define kind of what happens to the response once it matches the expression. In this case, I'm just going to send a 405 error and say the method is not allowed. So let's see that in action. In this case, I'm going to jump back over to my terminal window. Let's close this down. Hopefully everything is still running behind the scenes. And I'm going to take that and actually I'll show you what that policy file looks like in my IDE really quick. This is other methods. It's the exact same thing that I put on the slide. So pushing up the sleeves, no magic here. And I will start a new tunnel that adds my policy to my endpoint. So in this case, I'll jump back over here, and I am doing the exact same HTTP command, but in this case, I'm adding a policy file, and I'm adding that YAML file there. So when I run that, now I can go back to my API, which should still be up, And in this case, if I try to put a post to that API service, I hit send, I say the method is not allowed. So again, going back to what actually happened there, my agent took that policy file, pushed it up into the ngrok cloud. That policy is now distributed to our entire infrastructure, so that any request that comes in, that policy is now applied to that request at our edge, and only valid GET responses are actually passed to my service. In this case, I can send this. It's a GET request. It's coming through, and it's handling just fine. So a really basic example of how policy works, but you can start adding and making those more complex. And let's take a look at what that looks like. So jumping back here, I'll leave that up for anyone. The next thing, once you've discovered that people start hitting your endpoints with random HTTP verbs, you'll probably look at trying to stop them from doing that or rate limiting them at some point, right? And so let's take a look at the rate limiting action. So in this case, I'm going to do a really basic one that's going to rate limit by the client IP, and we'll get to a little more a useful example a little bit later, rate limiting by JOT token. But in this case, same policy structure, right? So expressions. In this case, my expressions are empty, and what that means is that it's just going to apply to all traffic that's going to my endpoint. I've added this rate limit configuration. In this case, it's going to be 5 requests per minute and a sliding window algorithm and it's going to be based on the client IP. So we can base this on anything we want from the actual request, and we'll see later how we can apply it to header values. But in this case, if I take this and add it to my endpoint, hopefully people will start start getting rate limited by their IP address. So what I'm going to do here, let's jump back over to my ngrok. I'll bring it down, and we'll bring up my new policy file, which is my rate limiting one, rate limit by IP. Again, just rolling up the sleeves here. This is the same thing that's in the slides, but in this case, we'll apply now 2 policies to our endpoint, because we can apply as many policies as we want. They'll get aggregated at our in our backend and applied to your endpoint. I've still got my other methods YAML. I could combine these into the same file. That's fine too. But now I'm adding a rate limiting by IP. I open that up, and now when I jump back over to my my demo here, let's see here. I will send a request. That's 1, 2, 3, 4, 5. Oh, I got rate limited, my 529, and hopefully you all got rate limited too. So again, what is this actually doing? It's taking the policy from my agent, pushing it up to the ngrok cloud, and applying that policy to all the traffic that's routing to my endpoint in real time, which is really exciting. I see a couple of questions coming through in the chat. I will answer them in just a moment. Don't worry, they're not lost on me. So we'll jump back to them towards the end here. All right. So we've applied some protections to make sure that we're not getting random HTTP verbs. We've applied some protections to make sure that we don't have a single IP that's coming over and berating or attacking our system. But let's add something a little more interesting. Let's add some authorization and verification to our endpoint. So as Karthik mentioned, one of the capabilities here is job verification. So what this will do is when people are accessing our endpoint, they're going to put a JOT token into their authentication header, and then we'll verify that, and only valid traffic will get sent to our endpoint. But let's start with a couple of basics. So one, since we're adding verification or we're adding authorization to our endpoint, anything that comes in that doesn't have an authorization, I'm just going to mark it as unauthorized, right? Very simple policy, but that will block, again, block at the ngrok edge traffic that's coming through that doesn't have any sort of authorization header. Next, I'm going to, again, this is we're getting into some of the more details here, but in this case, I've got two different expressions. I'm checking to make sure it does have the authorization header. I don't really need that because I've already blocked all the traffic that doesn't, but just to be safe. And then I'm actually checking to make sure that it starts with a bearer token, right? So I can actually grab the value of that authorization header and check in real time to make sure that we're actually seeing bearer tokens come through. Somebody could put in, random authorization header values. And then I've configured my my JOT validation here, right? So I won't go through the details of configuring JOT validation, but long story short, go into your ID, your identity provider, you grab a bunch of values, you copy them into the configuration file here, and then you can apply them. In this case, I'm going to basically just allow access to my API for this example. And then finally, I can make an update to my actual rate limiting code. So this is the same 5 requests per minute code from before, but in this case, I'm going to look at the authorization header value so that I'm going to rate limit by the particular JOT token that is actually being sent through the API. And so a little more useful than client IP. So we can check that out. All right. So let's apply that to our endpoint. Again, just to roll up my sleeves, I've got, let's see here, my rate limiting, or my JWT auth here. All the things that I saw, you've got the request header, you've got the JOT validation, and the rate limiting is somewhere in here. Oh, I think it's somewhere. I think it's this one. Sorry, the rate limiting is in there too. So everything should be good to go. What I'll do is I'll come over here and I'll take down my endpoint one more time. In this case, I'll grab the rate limiting file. Again, I'll keep the other methods one just to be safe. And now when I jump over here, the first thing I'll try to do this. I'll try to do one of these unauthorized requests. See what happens. Oh, all right. It doesn't have the authorization header. It's got a bunch of headers, but not that one. So I'm successfully getting authorized. Again, that traffic isn't going to my service. It's stopping at the ngrok edge and getting a response sent back. So I'm not no CPU cycles on my side for doing that. Now, this GET request actually has my JOT token connected to it. It's actually put into the authorization header and sent over. So when I hit that, the traffic goes to the ngrok edge. It grabs the JOT token, verifies that it's valid, and then forwards it to my actual upstream service. And so I'm able to access this. And again, just so I promised that I wouldn't type, and that's what happens. Wikipedia.org. That's why they say don't type during demos. Just to mix it up a little bit. All right. So just to recap, getting back to our actual demo. What have we done so far? Okay. So first, we provided access to anyone in the world with a single command, right? That's the ngrok HTTP 3000 or ngrok HTTP 80 that everybody knows and loves. I walked you through a little bit of how ngrok works at a 50,000 foot level. Then we started applying policies to our endpoint. So we blocked invalid methods at the ngrok edge. We started rate limiting traffic based on our client IP. Then we actually combined all of those pieces together and added JOT verification and rate limiting based on that JOT token. And the cool thing is, again, we did all of this. I didn't change a single piece of my code. I didn't change a single network setting on my side. and everyone was able to access that endpoint up until the point when I locked it down. And the really interesting part about this is I'm doing all this on my local machine. I'm demoing this all on my local laptop through my local network. But this works the same way no matter where you run ngrok, and no matter where you run your service, and no matter where you run any of this stuff. It's the same policy files. It's the same configuration. It's the same commands. And it just works no matter what. And that's really the power of ngrok, is that it truly is kind of the equalizer in being able to actually code against the connectivity that you're looking for. All right. So one of the things that always happens during these demos is I keep restarting my agent every single time, right? Every time you restart your agent, you have downtime, right? And so let's figure out a way to avoid that. We're going to move this over to what we call ngrok edges. What ngrok edges allow you to do is actually update your endpoints and policies directly in your browser, independent from your agent. And so your agent can sit there and keep executing, keep running, and you can go in and manage and configure anything in your dashboard that you want. We can apply these policies that way. And so really what we're going to do is we're going to take the exact same policy files, then we're going to put them into an ngrok edge. And we're going to connect our agent to that edge, and then we can make changes, and we won't need to restart any of the agents, which is really awesome. So in this case, I am going to first stop my local agent running, and I'll do that here. I'm going to jump over to the browser. This is the ngrok dashboard. For anyone who hasn't accessed it, dashboard.ngrok.com. Jump in here. There's a lot of cool stuff. We're constantly improving and updating this. I think on Friday we just launched dark mode, which is really awesome. And this is my edge that I've created for this gateway. I gave it a new URL, so it didn't conflict with anything that I have. And then in this case, what I have is a traffic policy module. And it should look pretty familiar. In this case, I've got all of my different policies copied in here. I did that right in the browser here. And I've got my GET requests, I've got my authorization, I've got my job validation, all that sort of stuff, ready to go. But in this case, I don't have any agents connected to it. And so let's connect our ngrok agent to our edge with a new command. So in this case, we have a slightly different command, slightly different syntax here, but should look pretty simple. I am creating a tunnel now that is going to my local port. And in this case, I'm using labels to connect it to the edge that I created. Now, this label can be anything, but by default, we just use the ID of the edge. You can go in and configure that to be a set of key value pairs that makes sense for you. And when I run that, what this actually does is opens up a connection to ngrok, and then it starts matching with any available edges that have that label syntax. And so in this case, I've got my tunnel online. I'm ready to go. And if I jump back over to Postman and jump to an API demo now, right, which is slightly different, I get back to my actual API. So what I've done here is I've got the same result, but I've actually moved all of the configuration off of my local machine and put it into a place that I can configure it in the cloud, which means that I can change those settings whenever I want without having to go to my local machine. And this is great for when you're running ngrok agents far away in remote locations, and you don't always have access to go in and change them. And also you want to avoid downtime. The other cool thing that this does is, if you notice in the browser, I've got one tunnel online. I can start as many as I want. And what ngrok will do is load balance traffic round robin across all of those agents and all of those services. And so ngrok has built-in load balancing for your services when you're using ngrok edges, which is pretty exciting. All right. So we've connected to the ngrok edge, but at the end of the day, we're still running a separate agent for that we have to start up separately from our application, right? And that could be a little bit of a deployment headache when you're actually deploying this into production. And as Karthik mentioned, you can actually build that capability directly into your API, which is really exciting. So in this case, I can actually embed the ngrok agent into my application. And when I say embed the ngrok agent, I don't mean like some sort of private binary that we reach out and we download and store on your machine. These are open source libraries. We've implemented the protocol that connects into ngrok in these libraries. There's one for JavaScript. There's one for Go and Rust and Java and Python and whatever language you need. And these allow you to actually build ngrok directly into your application and build that connectivity there. So in this case, what I'm going to do is jump over to my code, and I'm going to bring up the changes that I need to make. So I will pull up code. I jump over to my app, and through the magic of Git, let me just turn this off. Through the magic of Git, we will bring in the new ngrok library. So I didn't make any changes to my own code. I just made changes to the Express code. And what this does is actually creates an ngrok session, creates a listener. In this case, I'm using the same edge language that I was using before. And now I'm connecting to my ngrok edge. You can also apply policies directly into your code if you'd like. So if you want to build connectivity so that anytime you start your application, you get the same connectivity. You can build that right here. In this case, I'm just connecting to my edge, and I'll configure that later. And then and listening. Everything else is the same. No changes to my actual app. Just changes to how I configure Express. And now that that's set up, if I jump over to, I should still have a tunnel connected. Uh-oh, my resource isn't found. That's not good. I should have a tunnel connected, and then I can jump over to Postman and hopefully send this request and still get the same answer. So it looks like the same answer, but this is different, right? This isn't going through any local ngrok agent. This isn't going through any standalone thing that I needed to deploy separately from my application. Anywhere I deploy my application, as soon as it starts up, it creates a connection to ngrok, and it creates a connection to this ngrok edge. And so I can start 1, 2, 10 of these applications. That will also automatically load balance across all of those applications. And so if you need to scale or deploy, it's truly magic. This is very similar to how our ingress controller works in Kubernetes. It'll automatically scale this stuff and route to your API. So really exciting, really exciting stuff here. That is the end of my mega demo. And just wanted to get back to in closing here. So Karthik walked us through a lot of the details about ngrok and APIs and API gateways and their evolution. If you take one thing away from this presentation, right, is this idea of ngrok combines the pros of both deployable gateways and cloud gateways into a single package that your developers can use to accelerate their development and deployment to production, right? We're really designed and built for developers, and we're making a lot of the API gateway capability that was previously locked away available to developers so that they can build better applications. And I think that's it. So we're going to open it up to Q&A. As I mentioned, I think there were some questions in the chat that I wanted to get to. But one last plug, please join us at KubeCon and Cloud Native Con in Europe. We'll be there on March 19th to the 22nd in Paris, booth J30. And all of this stuff is available now. You can learn more at ngrok.com, sign up for a free account, and you can walk through all the things that I just demoed.
Awesome. Well, Karthik and and Russell, thank you both so much. We have received some questions. I know Karthik has been doing his best to answer a couple of those through the text interface. So I'm just going to start with some of the ones that maybe he hasn't touched on yet. So Emmanuel F asks, not quite sure what in reference to, but isn't this a security hole if anyone can publish anything in a company? And how do we prevent unwanted API exposure?
Yeah, great question. So we get that question a lot, and we actually have a ton of controls built into our product to restrict that. So a couple different ways you can protect that. So one, we have a custom ingress option that enterprises can deploy, which basically configures your ngrok agent to connect through a specific domain that you control instead of a domain that ngrok controls, and that's the connection from the agent to the ngrok service. And what that allows you to do is actually block all other ngrok domains on your network, right? And that stops anyone from opening up an ngrok endpoint that isn't tied directly into your ngrok account. We also have the ability to provide private IPs for that connection as well, if you want to connect directly into that IP address. So that's one. Two, once you have a developer in there, you can bind their auth token or the credentials that they use to connect to ngrok to specific domains that you control, right? And so in that way, your developer can't take that auth token, or if the developer, if they lose their auth token, people can't open up random endpoints anywhere in their network. And there's a whole host of other controls, but those are the two main ones. But that partnered with the improved observability you can get when you're routing all of your traffic through ngrok. We provide ops teams with a full observability stack that lets them see all requests and responses that go through the network. And so that increased observability, along with the protections that we have in place for our platform, really help with any of those security concerns.
And we also have RBAC SSO to make sure that only authorized users have access to the ngrok platform.
Mm-hmm.
Awesome. Great, guys. Our next question comes from Richard B. Now, Karthik, you did touch on this, but it looks like it was a pretty good question. I'll put it up on the screen. So while it's great to hide non-value added complexity and streamline undifferentiated heavy lifting, inevitably, some developers will have holes in their knowledge. Do you have hooks to help developers drill down into app functionality problems in an efficient way, such that developers fill in knowledge gaps as part of fixing the issue and don't cargo cult their way through?
Yeah, it's a great question. So I run into this a lot as a product manager, right? Is you want to hide a lot of the complexity when you don't need it, but then if something goes wrong, you want to make sure that you have the tools available to actually debug and triage that. And so it's definitely a little bit of a balance. What I would say is, one, the observability layer that we have built into our platform helps debug and triage a lot of those issues with you. We have, for any of our agent SDKs, right, we have a ton of documentation in place and a great community out there of people willing to help out if you run into issues and problems. To be honest, a lot of the agent SDK work is relatively new in the last year, but the engineering team is monitoring those open source repositories, and so anybody that runs into anything concerning can drop a note in there, and they usually get a response within 24 hours. And we also have a ton of documentation out there. So whether it's documentation in our APIs, documentation in the agent, documentation wherever, we're constantly contributing and improving that documentation so that and we monitor like the questions on Stack Overflow and the questions out in the community to try to provide answers. So long story short, it's a little bit of a balance. We want people to be able to build that connectivity and get going and moving really quickly. But when they move into production, we want to make sure that they have the tools available to debug those. And so having that level of detail through docs and community and support is really valuable.
All right, and it looks like we have time for maybe one more question here. So Emmanuel F asks, where is TLS terminated, at ngrok edge or at the published service?
Great question. You can do it either way. So if you would like to configure it so that ngrok terminates your edge and can see what's going through, great. You can apply a lot more capabilities and functions at our ngrok edge. If you prefer to terminate it upstream at your application, we can pass that traffic through to your application unterminated, so that we can't see anything. So end-to-end encryption is totally possible.
All right, well, gentlemen, it looks like that is the end of our questions for today, so I don't want to keep you longer, but I really appreciate the both of you joining us here on Techstrong Learning and providing us with not only the knowledge, but showing us how we can apply it and how everything works together. So thank you both so much for your time today.
Thank you. Thank you all for joining. It was great to see everybody.
Absolutely. So before I let everyone go, a couple of final reminders that we have been recording our session today and we'll be sending it to you via email here shortly as soon as we possibly can. You'll also find it available on the DevOps website. Just visit devops.com/webinars. I'll be contacting 2 of our most engaged attendees to give out a couple of $50 Amazon gift cards. So thank you so much for your chats, for your questions. And it is not too late to become eligible by filling out our post-webinar survey pinned to the top of the chat. I'd like to thank ngrok for sponsoring our webinar today. And to everyone here, thank you so much for attending. We appreciate you spending your time here with us at Techstrong Learning, and we hope to see you at a future Techstrong Learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, Russell and Karthik.
Thank you.